In the last video, we introduced the mole and molar mass, which allows us to convert from a mass in grams to an amount of substance in moles and a number of particles. In this video, I want to turn our attention to volume and thinking about solutions. We often carry molecules around in the laboratory in, for example, aqueous solution, in a solution of water. So how do we count particles that we're carrying around within a solution? Solution stoichiometry describes how to do this. So how can we count the particles of solute within a solution? Say we took some salt and dissolved it in water to form a sodium chloride solution. How can we count the number of sodium plus and chloride minus particles within this solution? Well, the simplest way is to use the concentration of the solute in moles of solute per liter of solution. This way we can use volume to count number of particles, right? Since these units of moles per liter allow us to determine a number of particles simply by multiplying a volume in liters times a concentration in moles per liter to get moles. This ratio of moles of solute to the volume of the entire solution is known as molarity, and it's probably the most important concentration measure. To know the molarity of a solution, of course, we have to actually know the moles of solute that we put in the first place, and so that kind of begs the question, how do we determine the moles of solute that we actually added into the solution? Well, there we need to return to molar mass and say that if we're dealing with a solid solute that we're dissolving, say, in a liquid solvent, the solid solute has a molar mass in grams per mole, so we can calculate the number of solute particles we dissolved in the solution using molar mass. We can go from mass of solute to moles of solute, and then moles of solute to molarity by dividing by the total solution volume. So let's look at a quick example of this in the context of tramadol. Tramadol is an opioid pain medication, and it has a molar mass of 263.4 grams per mole. I'll let you verify this on your own, but it's worth taking a minute to calculate the molar mass based on the formula that's given here. A typical solution might contain 0.005 grams of tramadol in 100 milliliters of water. What's the molarity of a solution of 0.005 grams of tramadol in 100 milliliters of water? All right, well, to calculate the molarity, we know we're going to need in the denominator the total solution volume. Because the solid gets dispersed throughout the liquid, we can assume that the solid takes up no volume once it's dissolved, and so the total solution volume then is 0.1 liters, right? What we need in the numerator is the moles of solute. But how do we get the moles of solute? Well, we need to use the mass of solute, which is given here, and divide by its molar mass or molecular weight, mW. So we take the 0.005 grams, I'll leave off the significant zeros here just to keep things simple, and divide by the molecular weight, 263.4 grams per mole. And you can see we're going to get a fairly small number of moles here, and this is pretty typical for kind of human scales of reactions and solutions. Small numbers of moles are pretty much the norm. About 1.9 times 10 to the negative 5 moles of solute. When we take this and divide it by the 0.1 liters of solution, we end up with 1.9 times 10 to the negative 4 moles per liter, and you'll often see moles per liter written with a small caps letter M, and that just denotes moles per liter in a slightly more compact form.